Start of question 3. We have two flying birds. I'm going to simplify them as F and V. F is a falcon, V is a turkey vulture. A turkey vulture, confusingly, is more vulture than turkey. And you know you're the background stars of this video, right?
Yeah.
So what I've got is, let's add details gradually.
Draw a picture, good. Picture.
That's my picture. That's good enough.
Oh.
Falcon's going fast,
Label your nose.
coming up on the vulture from, okay. Mass equals 0.06 kilograms. Velocity is 60 meters per second.
Is that the Falcon? Which one's, so what's
F is for Falcon. The vulture, mass equals 1.6 kilograms. You will notice I've simply done the conversion from the given quantities in grams. Initial velocity of the vulture. Probably not too early to make a direction axis. Let's call this plus, which means this is plus and this is plus. So after doing a couple of these solutions, you should be looking at this and thinking, okay, before the impact, I know the mass and velocities of both objects. So I know the total momentum in these two objects. Over the short period that this attack happens, there's no other forces that matter. So I can treat this as an isolated system of Falcon and Vulture. And when's a good after? Well, when they're stuck together. I would like to draw them stuck together with talons tearing into the vulture and beaks ripping flesh and feathers going everywhere, but I'm not that good at drawing. What is their combined mass? 1.6 plus 0.6 equals 2.2 kilograms. The question is, what is their velocity?
Isn't it 0.06?
0. The question is 600 grams equals.
No, just because that's what you have right now.
Oh, good point. Yes, good.
Hey, Mr. Mott.
Found a boo-boo. The mass of the Falcon is not 0.6 kilograms, but 0.6 kilograms. Because 600 grams, I'll be right with you, times 1 kilogram is equal to 1,000 grams equals 0.6 kilograms. A question.
I know that.
4 minutes, I know. But I'm abbreviating some steps here. No change, no interactions. So to go from bar chart to math, the initial velocity of the vulture plus the momentum of the vulture plus the momentum of the Falcon equals the final momentum of vulture plus Falcon times the velocity. This is just okay, let's substitute these out. The momentum of the vulture, 1.6 kilograms, times 14 meters per second, plus the mass of the Falcon, times the speed of the Falcon, equals the momentum final of Vulture plus Falcon. That means that this calculation shocks no one. Multiply that out. We get 58.4 kilogram meters per second.
Divide that by the weight. That's what you do.
Then what we need is the final velocity of Vulture plus Falcon. That's equal to momentum of Vulture plus Falcon divided by the mass of Vulture plus Falcon equals 58.4 divided by 2.2 equals 26.5 meters per second. Biology, real world. What do you think is most damaging to the vulture about this attack? Is it the claws?
Speed of the other bird.
I think you're right. It's the impact. It's taking this much of a change of momentum so quickly. Basically, when falcons attack like this, they break their prey. All right, it's broken. Can't fly anymore. Learning about the evolutionary adaptations of falcons to do this is very interesting. Like they have special structures in the bones of their skull to absorb the impact, and it's just really, really interesting. They're designed as little fighter planes to do this, and I use designed in a strictly metaphorical sense. Any questions about solving this problem?
For the bar chart, what would you put in the bar chart?
Well, this is some number that we know. This is some number that we know. Okay, we've calculated this number. We've calculated this number. That means that we can find out what this number is. Again, this is not the only way to solve this problem. You could solve this in many different, with many different methods. Okay, end of problem 3.